So what we want to start doing is looking at points in the xy plane, the Cartesian coordinate system. So let's suppose that I take this picture of a coordinate grid over here on the left. And let me just label a point on it. So how about this one right here? All right, so I just labeled a point. What is that point? What kind of information do we need in order to describe that point and to distinguish that point that I labeled from all the other points that live on the xy coordinate plane? Emma?
Where it's located, like on the y and x.
Okay, great. So the traditional way that we locate a point in the coordinate system is to figure out where this point lies along the x direction, where this point lies along the y direction. Each of those is going to give us a number, and we just bundle those two numbers together in what we call an ordered pair. So, for example, an ordered pair is a pair of numbers, naturally, separated by a comma in between them and with parentheses on the outside. And one of these numbers is going to tell us the x, the horizontal location of this point. The other number is going to tell us the y, the vertical location of this point. Which goes where? Which comes first in this notation and which comes second, the x or the y? The x. So this is, again, convention. This is how we think of ordered pairs. The x-coordinate is the one that we write first. The y-coordinate is the one that we write second. And we call them ordered pairs because that order matters. Right? If I flip-flop the x and the y, in general, I'm going to get a different point than the one that I started with. So just make sure that in your notation, the x-coordinate is listed first, the y-coordinate is listed second. So now we know what kind of an answer that we're looking for. How can we figure out what number x and what number y correspond to this point in particular? Keela?
How far is it from the origin?
Sure. How far is it from the origin, measured in what mathematicians like to call the taxicab metric? It's a bit like we're looking at a big street map of New York City or something, and starting from the origin. By the way, what is the origin? What does origin mean? Jamie? 0, 0. It's the place where the x-axis and the y-axis connect. And it's called the origin because it's kind of where all the coordinates in this coordinate system originate from. The point whose x and y coordinates are both 0. So starting from the origin, you can imagine taking a taxi cab along the street lines, and these street lines are the grid lines on this graph, that begin from the origin and end at the point that we're trying to describe. So for example, if I decide I want to drive east first, then how far east I drive is going to tell me my x-coordinate. But I haven't quite given you enough information on this graph to decide on exactly how far that is. What's missing? What should I do to help you to make this process more meaningful? Yeah, we need to know on these axes how far are each of these little coordinate lines that we're crossing, right? How long is a block if we want to continue with the taxicab metaphor? So let's suppose that just for the sake of having something written down, that I decide that each of these blocks is one step on the number line, so that as we go from left to right, we're going 1, 2, 3, and so on. If that's the case, then how far to the right have I gone, in this example, to get all the way out to my point in the x direction? How many lines did I have to cross? 7. And therefore, the x-coordinate of the point in question is going to be 7. So that tells me the x-coordinate, which is, again, the one that we're going to put first in our ordered pair. And then the second part of the question is, what about the up and down? Right? How many blocks north to south do we have to drive? What's the scale on my y-axis going to be? Well, first of all, yeah, that's a good observation, is that our y-coordinate for this point is going to be negative. How do you know? For this point, why is the y-coordinate negative? The opposite direction? Well, opposite from what? Well, so, and this is another convention, sort of, right? That in our coordinate system, the values of y as we go up are going to be positive. This is going to be a really important observation for later when we start talking about slope. Positive values of y are going to be up on the graph. Positive values of x are going to be to the right. And then once we've fixed that, then we can talk about their opposites. Right? That if I go to the left instead of to the right, then I have negative values of x. Whoops. Negative values of x live to the left, and negative values of y live down. And so because our point lies underneath the x-axis, because we have to go down to get from the x-axis to our point, its y-coordinate is going to be negative. Now, we don't know how negative until we decide what the scale on this axis is going to be, but we know it's going to be a negative number. And another point that's important to mention is that the scale that we choose to mark the grid lines on the y-axis does not have to be the same as the scale that we use to measure the grid lines on the x-axis. Here I chose 1, 2, 3, and so forth for the x-axis gradations, but maybe, just for the sake of doing something different, we choose something else on the y-axis. Maybe they go 3, 6, 9, 12, and so forth. So if in the y direction we're counting by threes, what is the y-coordinate of this green point? Negative how much? So it's negative, it's 2 grid lines below the x-axis. But if each of the grid lines in the y direction is counting by threes, then what is the y-coordinate of that point? Yeah, from 0 to -3 to -3 plus -3, -6. So there's a couple of important points about this. The first is that in ordered pair notation, the x-coordinate always comes first. Okay? So x first, y second. So if you're labeling the location of a point, look to the left and to the right first for the first coordinate, and then look up and down for the y, the second coordinate. That's the first point. The second point is the particular numbers that are there depend on the scale that's chosen on the axes. So if there's no scale specified on the axes, you either should specify one, to make sure that the reader knows what the scale is, or if it's not there and it's important to the question and it should be there, ask your professor, right? Maybe I forgot to put it in there. But in general, the best practice is always to include that scale so that anyone reading this graph is going to know what the scale is on each of those two axes, because the scale really matters. And so with this kind of navigation, now you can find the location of any point inside of this coordinate system.